So far we discussed with the concepts like how disk blocks are going to be allocated, right? They can be allocated in the form of either contiguous or non-contiguous or indexed fashion, right? And then we have seen how disk blocks free space is going to be managed, right? Now next concept is disk scheduling, which means that once we identified what are the free spaces are there, right? So we have allocated one block. In this block we thought that disk block 2, 4, 6 are free. Then in these 3 blocks, how you are going to allocate the data, how you are going to place the data, right? You follow the approach of contiguous or non-contiguous, what it might be. You all decide everything. Then for which process or for which data you have to place, that's the next question. That will be defined by disk scheduling algorithm, right? So I mean, if I am going to have n process request, if I am going to have n process request, I want to store this data, I want to store this data like that, then which request it will satisfy first? Which request it will satisfy first? That will be defined by disk scheduling algorithm. Right? Why they will request for the disk? In order to perform IO operation. Am I right or not? Input output operation means what? In order to perform read or write operation, they are asking for the respective disk, right? So when multiple requests are coming into the picture, how many requests are going to be satisfied at a time? Only one request is going to be satisfied, right? In the second unit of CPU scheduling, we have covered that at a time only one process is going to be executed, but in general we thought that many tasks are going to be executed, right? But even we are going to have n number of processes, only one request is going to be satisfied. What about the remaining things? All the things are going to be in the queue, right? So which one is going to be satisfied first? That will definitely impact the performance of the system. Am I right? Performance of the system will be definitely impact. So that is the reason we are going to worried about which one we have to give first and which one we have to give prior to the last. That will be defined based on the disk scheduling algorithms, right? We are going to have various kind of scheduling algorithms are there. We'll look into one by one now. Okay, fine. So before going for further various kind of algorithms, I already mentioned that we are trying to move from one track to another track. This is what we call it as seek time, and once you move to respective track, you have to move to the respective sector. This is what terminology we call it as sector. This center thing we call it as sector. In this sector, this is what we call it as block. This is a block. This entire thing we call it as sector. So once we go through that video, you can get the clear idea, right? So here the point is, the one more reason why we are studying the concept of disk scheduling is how much efficiently you are going to access the data, right? If you want to access the data efficiently, if you are able to reduce the seek time, that's a better one, right? So the main goal of disk scheduling is to minimize average seek time, and which in turn will improve the performance of the system. Is it okay with everyone? This is introduction part. So what is the main goal behind disk scheduling algorithm? In order to reduce the accessing time of the block, right? That I can call it as minimizing the average seek time. So first kind of algorithm will be FCFS algorithm. What do you think of FCFS? First come, first serve, right? So first come, first serve algorithm. we come across this kind of algorithm at many ways, right? CP scheduling algorithm, and in the last class FIFO, first in first out, paging, right? Page replacement algorithm we have seen, right? So everywhere the same meaning. So first come first serve, what it means is the order in which the request will come, in the same order will serve the request. This is what the principle behind first come first serve. Okay, fine. For example, let us say, so here you have to have many assumptions. Let us say there will be 200 disks blocks. Let us say there will be 200 disk blocks, right? So I am assuming that those disk blocks will be represented something like this, which I can represent like this 0. Okay, anyhow, so before going this one, we'll try to define what are the various kind of incoming requests that we got. Assume that the request I got from the process are 82, 170, 43, 140, 24, 16 and 190. What is the meaning of this one? These are the disk block addresses. I got the request to access these disk block addresses. In order to access these disk block addresses, what is the approach that I am following? First come first serve, right? So what is the minimum criteria that you have to know? Can I start directly at the 0th position, or the system is already at some position? The system might be at some position, right? So that is the reason you require one more point. What is the current position of the disk? What is the current disk position? Assume that current disk position will be 50. Assume that current disk position will be 50. When the current disk position is 50, the disk is going to be rotated, right? So I can call this as cylinder sum. There are 200 cylinders are there. They will be in the form of cylinder wise only, right? If it is a kind of one disk, if you are going to place all the disk in one by one, how it will look like? It's a kind of a cylinder only, right? So there are 200 disk cylinders are there, and the requests are in this fashion, and the current position is 50, right? For the sake of our understandability, I am trying to represent in the form of serial wise. What is initial disk cylinder? 0, and I can represent like 1, 2, 3 and so on 200, but it will be a difficult one. That's the reason what I will do, I will try to write all the things in a sequential fashion. So that will be easiest one. So once you understood one problem, you can able to clearly understood. What is the next number? 16. Given numbers I am writing them. See, in general you can write 0, 1, 2, 3 and so on 200, but trying to write all those things will be a time wasted process, right? That's the thing I am writing. 0, 16, 24, 43, 82, any other things are there? 140, 170, 190. How many cylinders are there? 200. If I start with 0th address, what is the last cylinder? 199. Total 200. 0 to 199. Okay. So now the system is already at some position. Let us say I am trying to note down them like this. The system is already at some position, that is 50. So can I note down this 50 as like this? Just for sake of example, right? So if my pointer or a plotter will be here, how the disk will move, the plotter will move in an FCFS fashion. FCFS fashion means the order in which the request will come. So first, for what process it will serve the request? 82, which means it will move from 50 to 82. Request from 50 to 82. After serving the request from 50 to 82, then it will move to which location? 170. After serving the request 170, then which will satisfy? 43. So I am trying to write approximately, not the exact one. Okay. 43. After serving the request 43, so try to observe, this is direction should be changed, right? If it has to move from this to rotation, this, see, this is something like this, 0. If this is 0, this one will be once again 199. Have understood? If something like that, right? So 43, then it has to move to what? 140. Then it has to move to it has to move to 24. Then it has to move to 16. Then it has to move to 190. Okay, now fine. So this is what we call it as FCFS algorithm. How it has served the request, right? So here you might get various kind of questions. What is the cardinality of this request? What is the cardinality? That they will ask, right? So cardinality means how many times it changes the direction. How many times it changes the direction, we call it as cardinality. How many times it changes the direction, or we can say that how many times it changes the head movements. We can call it as head movements, right? So how many times, right? So initially it will be in the forward only. One time. See, this is forward, we should not consider because it is in the same position. And then it moved towards the left side. That is, one time direction changes, second time direction changes, third time direction changes, and fourth time direction changes. So cardinality will be 4. Okay, na? Fine. And one more factor you have to calculate. What are the total number of tracks change? What are the total number of tracks change? How many total number of tracks change? That you have to consider. Tracks change means what? Every number is one track. 0th is one track, 1 is one track, 2 is one track, like that, right? So then, how many tracks change? So can I calculate like this? So here to here, how many tracks changed? 82 minus 50 tracks changed. This one, 170 minus 82 tracks changed. This one, 170 minus 43. 170 minus 43 tracks changed. This one, 140 minus, sorry, is it right? 140 minus 43. Second one I am writing. Third one, 140 minus 16. Okay. Can I write directly 140 minus 16? 140 minus 24 I can write. Similarly, 24 minus 16 I can write. This one, last one, 190 minus 16. If you are able to sum, that is the total number of tracks it has changed. What is the answer? right? See, you might get question here, sir, can you write them directly or not? Can you write them directly or not? You can write it, right? So for the sake of first example I made, so this entire thing I can call it as 170 minus 50, and this is as usual 170 minus 43, this is 140 minus 43. These two can be combined as 140 minus 16, and this is as usual, right? Try to calculate 170 minus 50, 170 minus 50 plus 170 minus 43 plus 140 minus 43 plus 140 minus 16 plus 190 minus 16. What is the sum? Six 53 or 642 642, is it correct? Right? 642 is the total number of tracks it has changed. Right? So in order to satisfy all these requests, we come up with this one. Right? You can calculate it. Fine. So then, for example, if they have given something like that, in order to move from one track to one track, in order to traverse one track, it will take 1 nanosecond. Then how much time it is going to take? 642 into 1 nanosecond, that is 642 nanoseconds it is going to take in order to serve all the requests. Okay, now fine. So here in this particular approach, what might be the advantages? As like as FCFS of CPU scheduling algorithm, does every request is going to be satisfied or not? Every request is going to be satisfied definitely after a certain point of time, right? So I can say that every request will get fair chance. Every request will get fair chance. Means there is no indefinite time for one particular process. But when you go with some kind of priorities, what will happen? The lower priority process will definitely will be in the infinite state, right? But here in the FCFS there is no problem like that. But what will be the disadvantage? We are not thinking about seek time here, right? But our main aim is what? To minimize the seek time. But we are not thinking about the seek time. We are simply moving forward as per the request, right? So that's the problem. So this particular approach doesn't optimize the seek time. Doesn't optimize the seek time. So to overcome this problem, we are moving with another kind of approach. We call it as shortest seek time first. So what is the meaning of this one? The name itself clearly providing. When you are trying to serve the request, you have to always calculate the shortest seek time, right? So you can note down the definition. Request having the shortest seek time or executed first. Then how we are going to calculate the shortest seek time? Right? For example, the same kind of request means 82, 170, 43, 140, 24, 16 and 190 are there. So in order to define them in cylinders, total 200 cylinders are there. So those ranges from 0 to 199. Tell me. 0, 16, 24, very good, 43, 82, 140, 170, 190 and the last one is 190. Anyhow, the starting one and the last one should be definitely written, right? In middle, sir, can I write 150? It's our wish, there is no problem, right? So for the sake of simplifying from our end, I am trying to write only the given things, right? So what this shortest seek time algorithm is defining, before moving further, I have to first calculate seek time. Seek time means what? From my position, next to where I am moving, that should be very less, right? So first, for that, first what you require? Very good. What is the current position? So as per the earlier example, I am continuing. I am trying to take the current position as right. So now, before moving the first request, what I have to do? I have to calculate seek time for all the requests. What is seek time for all the requests? So you have to calculate it. So instead of calculating all the requests, what you can do, right? As we mentioned them in the sorted order, what is the difference between the 43 and 57, and what is the difference between 50 and 82? 32. So which is the better seek time? 43. Hope you understood. In general, you have to calculate seek time for everything, and you have to identify the best seek time, and you have to go with that. As we mentioned them already in the sorted order, it's better to mention them directly. Right? Now, from 43, what is the better seek time? So 43 is done. Obviously, 43 to 24 is how much? I think 19, and 43 to 82 more than 50, right? So I can serve for only 24. Then 24 to 16 is better or 82 is better? Obviously 16 is better. From 16 to which one is better? Obviously you can go with this one, right? Because already in sorted order you can go. I think all requests are served. So this is the SSTF algorithm. Okay, now any confusion? Right? Now try to calculate number of tracks. What is number of tracks? 50 minus 16 and 190 minus 16. What is their sum? Huh? 208, right? So 208, right? So based on the problem, if they have given the nanoseconds, you have to take it as that many 208 into number of nanoseconds it has required, right? So total 208 nanoseconds required for SSTF. But the same request, if you want to satisfy in the FCFS, how many nanoseconds it has taken? 642 nanoseconds, right? So this is what this algorithm is going to define, right? So then, what is the advantage of this particular SSTF algorithm? Right? This is the algorithm which is the best one. Best algorithm which will satisfy, which will provide, which will give minimum seek time. Right? So as I am saying that minimum seek time, as it is giving the minimum seek time, I can say that in terms of seek time, does throughput is increasing or not? Yes. This is the advantage. But what about the drawbacks? What are the drawbacks? One thing will be overhead. What is that overhead? For each and every process request, you have to every time calculate seek time, right? So overhead you have to take, right? Or you have to calculate seek time for every new request. I have to calculate for every new request. And one more thing will be there. Does there any starvation? Definitely there will be a starvation, right? So starvation will be definitely there, right? Because if there is any incoming request, as here I have taken only like all are statically, but if there is any process that come with very less seek time difference, always it has to satisfy that only, right? Then the higher track number will always have to wait for long time. So these are the two drawbacks that are there in the SSTF algorithm. So next kind of disk scheduling algorithm, scan. The algorithm name is scanum, right? So how it will work? There is no full form, it's only scan algorithm, right? So scan means it will, the general meaning, if you are able to understood, when I am in the one scan, I will try to continue my scanning in the same direction. Once I complete all the requests in the same direction, I will get back. That's the meaning of this one. Okay na? Which means that, so let us say, see, I will try to write down clearly. Discom moves in particular direction. Discom moves in the particular direction and services in the same direction. And service in the same direction. Once it completes its task, I mean after reaching the end of the disk. This is important, amma. After reaching the end of the disk, it reverses its direction. And again continue its service. Right? Hope you understood this one, right? Once I am in one scan, I will continue that scan until I reaches the end of the disk, and then I will change its direction and I will try to satisfy all the requests until I will complete all my process, right? With the example you can get more clear. So what are the numbers are there? So 82, 170, 43, 140, 24, 16 and 190, and obviously you required here what? Current position of the discom, assuming that 50, and here one point I have explained. Once I am in one direction, once I am in one type of scan, which means that what? Here required direction also. Which direction it is moving, right? So based on the description you can understood. Right now I am saying that right side. Right side means what? Towards higher number side. Towards higher number side, right? So based on this data, can we able to draw again the discoms? 0, tell me, 16, 24, 43, 50. So why I have drawn the 50? So because it is the current point. 50, 82, 140, good, 170, 190 and 199. So what the scan algorithm will do? Scan algorithm will start from the current position and will try to look for in which direction presently I am. I am in the towards the higher number side, so I will go towards the right side. 82 satisfied first, and then 140 satisfied first, and then 170 satisfied first, 190 satisfied, and will it change its direction? No. The algorithm is clearly saying that after reaching the end of the disk, means it will move until the end. This is the algorithm, will define that, that's it, right? This algorithm will move until the end, then it will move back and will try to solve the remaining request, 143 and 24 and 60. That's it. This is what, right? This difference is important after reaching the end of the disk, right? Now calculate the total number of tracks. So 199 minus 50. This is what? 199 minus 16, which total sum will be 332. Sum will be 332. Okay. Then what will be the disadvantage here? Okay, seek time anyhow increased compared to the earlier algorithm. So SSTF algorithm. SSTF is the algorithm, the best one. So seek time is increased. The disadvantage here is we are going to unnecessarily move to the end of the disk. So once you satisfied 190, does you need to go for 199? I mean 190 to 199? No need. So I can say that disadvantage here is we are going to unnecessary move to the last disk, right? This is the drawback. To overcome that, we are going to go with one more kind of algorithm. That algorithm is look algorithm. Look, L-O-O-K. Guys, this scan algorithm, I will call it as elevator algorithm. Why it is elevator? First, whichever the direction I am having, I will move that, then I will down it. Step up and step down. That's why scan algorithm also called as elevator algorithm. Next kind of algorithm is look algorithm, which is similar to scan algorithm, but what is the difference? It doesn't go till end of the disk block. That's it. That is the only difference between these two. Okay, fine. So that means I can write more technically. It will look up to the last pending request. It will look up to the only last pending request instead of moving for the till the end, right? So now tell me the sequence, or I will directly write them. 0, 16, 24, 43, 82, 140, 140 or 142? 140 na? Okay, earlier we discussed only 140. Okay, good. 140 and 170, 190 and 199, right? So it's simple. So anyhow, let me write them. 82, 170, 43, 140, 24, 16 and 190, and you have to know current position. Current position is 50, and here you require what? Direction. You require move towards higher track, and we are using algorithm called look algorithm. When you are going for look algorithm, what it will do? It will start with 50 and it will move towards the right side, and then it will stop here and then come back. Then what will be the answer for this? Which is 190 minus 50 and 190 minus 16, which is equal to 314. Is equal to 314. This is what look algorithm, right? Any doubt? No. Doubt in okay, good. Next kind of algorithm will be C-scan algorithm. Very good. C-scan, not the C-look. First C-scan algorithm. So C-scan means here it is circular scan, right? Earlier what happened? We are going to move towards the one direction and reaches the till the end and will come back. Right? Try to observe. We will move till the end 199 and will come back. Instead of coming back, it look like a kind of circular fashion, right? So once I reaches the end, I will come back here only. That will be defined by the, so we can say it as DISCOM arm moves in circular fashion. DISCOM moves in the circular fashion. Let me take the example. Same number. So the numbers are like 82, 170, 43, 140, 24, 16 and 190, and current position is going to be 50, right? And moving direction towards higher track value. When you do it like this, you can note down. So 0, 16, 24, 43, 50 I am going to start, and then 82, 140, 170, 190 and 199, right? So C-scan is same as like scan. So means what? I will try to scan in the same direction what I am trying to look. So 52, 82 and 82 to 140, 142, 170, 172, 190, 192, 199, right? This is what scan. Then in scan what is happening? We will try to come back in the same direction. Try to come back in the reverse direction. We will try to come back like this, right? But in C-scan, instead of coming like that, what it will do? It will move in the same direction, so that cardinality will be reduced. There the cardinality will be 1, now cardinality is going to be 0, right? So which means I will try to start with this one, right? Understood. Zero, 16, 24 and 43, right? 199, after 199 you will get again 0, then I will come back. This is what C-scan algorithm will define, right? Based on that, what will be the answer here? 199 minus 50 tracks, and this will be 43 minus 0 tracks. Then what will be the answer? Total 391. Here you have to consider moving from 199 to 0 also, right? So I mean, so this is important one. 199 minus 50 plus at the back what is happening you have to note down. 199 minus 0 plus 43 minus 0. Those has to be considered. Right? This is how C-scan is going to work. So total it will become with 391. So what is the next algorithm? C loop, right? C loop will be same as loop, but what is the difference? Discom will moves until what? Pending request. But what about the C-scan? Will go for end. So C-scan drawback will be overcome by C loop. So in C loop, Discom goes for only, moves for only up to Discom will look up only up to pending request. That's it. So if I take the same example, what are the numbers? So I will try to note down 0, 16, 24, 43, 50 is my current position, and 82, 140, 170, 190 and 199, right? So if I note down those numbers, 82, 170, 43, 140, 24, 16, 190, current position will be 50 and direction will be towards higher, right? Now how we are going to solve this one? Try to observe. So it will start with 50, and towards the higher direction. So 82, 140, 170, 190, right? In the back it will come back and it will start with 16, not with a 0. Start with 16, not with a 0. So these are the differences that you have to observe. 16, 24 and then 43. So anyhow this will be at the logical part, right? So total, what is the value? 190 minus 50, 190 minus 16 and 43 minus 16. The total value will be 341. 341, right? These are the 6 types of algorithms that will be comes under disk schedule algorithm, which are important for the gate. And there are many kind of other algorithms are there which are not required for this. Okay. So I have understood all the 6 algorithms, which are very simple. First come first serve based on the request, and then shortest seek time first. You have to calculate the seek time for every process, and then scan will move in the same direction until end and look until the pending request. C scan, instead of getting back, will get back from the circular fashion. In C scan, C loop, instead of going for end, the back until the end, will get back only up to the pending request, right? So note down one question. This is gate question. I haven't remembered the year. Consider a disk queue. Consider a disk queue with request for IO operations to the blocks on cylinders to the blocks on cylinders 47, 38, 121, 191, 87, 11, 92, 10 and 10. Okay. The C-loop scheduling algorithm is using the C-loop scheduling algorithm is used the head is initially at the cylinder number 63. It's number 63. What are the other parameters required for C-loop? Direction, right? So initial at cylinder number 63, moving towards larger cylinder. Moving towards larger cylinder, larger cylinders. The cylinder numbers, the cylinders are numbered 0 to 199, 0 to 199. The total number of head movements. Total number of head movements. Bracket lo in number of cylinders amma. Head movements while serving this request is, this is a numerical question. Right? So the question looks very simple. So can you tell me the answer? Right, so on reading this question you can understood that they are using C-loop algorithm, right? What the C-loop algorithm will define? It needs the direction and it won't go for until the end. That's simple. So I will try to maintain their data in some short order. It will start with 0. Okay, that's good, right? So we can note down the numbers in the short order. 0, 10, 11, 38, good. 47, 63 is the current position, good. I will note down them, that also. 87, 92, 121, 191 and then 199, right? So you have to clearly understood this is C-loop. In C-loop, the current serving request is 63 and the direction they have given as moving towards the larger cylinder. You have to compulsory know that, otherwise you can't able to solve it, right? So I will go 87, 92, 121 and 191. Can I move further?
No, sir.
No. If it is scan, I'll go further. If it is scan or C scan, I will go further. But in look or C look, I won't go for the end. Right? So I will stop here and I will come back logically. Right? It is circular fashion. It is circular fashion. I will come back logically. Then I will serve the request from here. 10 to 11, 11 to 38, 30 to 47. Then calculate that. 191 minus, good, 191 minus 63, 191 minus 10, 47 minus 10. What is the total value? 346. So it is the correct answer, right? While serving this request means all the requests are satisfied. 190. You have to consider everything. So see, but in order to complete the remaining request, you have to consider all the things, right? So until the end of the request, while serving this request means what? While completing, like till completion of all the requests, what is the number of tracks changed? So answer will be 346. So next, note down the last one. This is also one of the gate question which was asked in the year 2014. Suppose a disc has 201 cylinders. Numbered from 0 to 200, right? At some time the disc arm is at cylinder 100. And there is a queue of disk access request. There is a queue of disk access request for cylinders. 30, 85, 90, 100, 105, 110, 135 and 145. If shortest seek time first is being used for scheduling the disk, shortest seek time first is being used for scheduling the disk access, comma, the request for cylinder 10, the request for cylinder 90 is serviced, after servicing dash the number of a request. Read the question carefully and try to answer it. Right? So there will be 201 cylinders. Those numbers from 0 to 200, and initial position is what, ma? 100. The disk arm initial position is 100, and there is a queue of request, something like that they have given. If the algorithm they are using as SSTF algorithm, shortest seek time first algorithm, when the cylinder number 90 is serviced after servicing dash number of requests. It's 2 numbers. See, you have to understand the clearly question. 4, 3, all four options done. Right? So we'll try to solve it so they can get the clear idea. So first, initially what you have to do, you have to note down that 0. What is the next number? 30 number. 30. 85 direct. Good. 90. 100. 105. 110. 135. They are in already sorted order. Okay. Right? So this is what the data they have given. Now what is the cylinder they are at? They are at current position is 100. Right? So, and the algorithm what they are using is SSTF. So in SSTF, whenever you are going to process the request, first you have to find out the shortest seek time first, right? So what is the simple logic? You can calculate adjacent, right? What is it? So which will service to 90 or 105? 105. So which is servicing to 105. So 105 done. 105 done. Next 105 to 90 or 110? 110. So 110 done. Next 110 to 135 is better or 90 is better? 110 to 90 is 20. 110 to 135 is 25. So 90 is servicing, right? So the request for cylinder 90 is serviced after servicing the dash number of requests. What are the number of requests?
100 also there, sir.
Right? So that you have to consider. 100 is done. 100, 105 and 110, then third one. So the answer will be 3 number of services. So these 3 done. Right? You should not worry, consider the 100 because 100 is also one request. So 100 request is done, 105 request done, 110, then 90 is supposed to serve. For that it satisfied 3 requests. Okay, now fine. So we can stop here.